Thank you for joining us this morning for this webinar on recipe management. So it's a two-part, so we'll have part two next week. The first part's roughly about 20 minutes, and as usual, if you have any questions at any point, you can just put them into the panel and we shall get to them at the end.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we're looking at Cscape recipe management, and this is the first part in a two-part series. First, I'll look at what are recipes in Cscape. Then we'll talk about Cscape's recipe tools, including the recipe editor and the graphical logic that's included with the recipe function. We'll talk about the workflow when incorporating recipes into your application. We'll have demonstrations throughout, and as always, we'll finish with a Q&A session. So what are recipes in automation? By definition, a recipe is a set of instructions for making or preparing something, including a list of ingredients. Another definition is that a recipe is a formula for or a means to a desired end. Cscape's recipe tools are used to allow process parameter settings to be applied using a spreadsheet to allow the repeatable production of a variety of products. Let's look at the Cscape recipe tools, starting with the recipe editor. The recipe editor is the main tool that Cscape uses for handling recipes. It's what allows Cscape and the OCS at runtime to handle recipes as ingredients and products in rows and columns on a spreadsheet. You can think of every ingredient as a process variable. For example, the temperature set point, water volume, pressure, etc. Then, each product is the result of running your process with a unique combination of set points for each process variable that's being managed by the recipe function. The spreadsheet being used is a CSV formatted file that resides on the microSD card at runtime. Next, we'll look at another tool, which is the Cscape graphical recipe object. This recipe object can be configured for 4 different functions. The first function you can use is the view indicator. That allows you to indicate on the screen what the current selected product recipe is. The other 3 functions you can use are all buttons. The first is a load button. When pressed, it allows the operator to select the product recipe that's to be loaded from a pop-up window that appears with a list of all the different product recipes available. And then one of those can be selected by the user. Then, those ingredient settings are all loaded into the process variables that are being managed by the recipe function. Similarly, there is an edit button that you can configure. This allows the user to modify the set point values for any of the editable parameters. Finally, we have the save button function. The save button allows you to overwrite a product recipe that you may have changed with the current ingredient values. Once again, if the operator presses the button to save the recipe, a pop-up window appears where they can select the particular product that needs to be saved using the current settings under the ingredient list. We also have some ladder logic function blocks that are available. Those are the load recipe function block and the save recipe function block. Well, why would you want to use these? The functions mentioned with the graphical recipe object were all triggered by the operator. Instead, you may want that to happen automatically. Maybe you want the machine to automatically load a particular recipe based on the part that is going to run next, so then you could use a load recipe function block. There is also a save recipe function block for automatically saving a product recipe. For example, if your OCS or your application program is automatically changing some of the parameters in the process, you may want those parameters to be saved back into the standard recipe. Now let's go through the workflow for adding recipe functionality to your application. Typically, you're going to add recipes toward the end of your application development cycle when you've everything set up the way you want. First, you need to make sure that any process variables that are impacted or modified by recipes have already been created. Next, I like to start with a spreadsheet to set up my recipes. I typically use Excel or some other spreadsheet program for this. In the columns, I'll add my ingredients, and in the rows, I'll add my products. Once I've done that, I export that as a CSV file. So I'm ready for Cscape to import that information. Starting with a spreadsheet is not a requirement. If you choose, you can skip that spreadsheet step and just open the recipe editor in Cscape. And that's available from the Cscape program menu. The first time you go into the Cscape recipe editor, Cscape is automatically going to prompt you to create a new recipe. It's going to ask you to name it and to assign a file name for that particular recipe, because at runtime there is a CSV file that has to reside on the OCS's memory card in order for the recipe function to work properly. You have to name that file in an 8.3 format, for example products.csv. Then you're going to size that file for how many products and how many ingredients you want. Next, you're going to do what's called configuring a product variable. When you're running your machine at any given time, typically you'll have a specific product that's been selected, and those recipe parameters are going to be loaded into the ingredient variables for that product. So it can be very helpful within the logic to be able to see what product recipe is currently being executed. Here you have two choices. If you want a numeric index, you can assign a numeric variable to the product variable, which is an integer. Or if you want to use the name, you can assign it as an ASCII variable type, which is a byte type array of up to 32 characters or 32 bytes. This is my preferred workflow. Keep in mind, I started out by creating a spreadsheet that had my recipe information on it, and I exported that as a CSV file. If you do that, next from the Cscape recipe editor, import that CSV file. Cscape will then automatically import the data from that CSV file that we created in Excel, including the products and the values for the ingredients in the recipe. What is not important here is the ingredient names, because ultimately we have to click on every ingredient and configure it anyway to assign a name, but also to tie it to a specific process variable in your program. If you choose to skip the CSV file import, then you still need to manually name all your products and ingredients and tie them to a variable. You do have the option of setting the initial values of your variables for the specific product. Next, once you're done configuring the Cscape recipes, you need to make sure that that CSV file ends up in the micro SD card in the OCS. You can allow Cscape to handle that for you by going to the Program and Download Options dialog and setting how Cscape chooses to download the CSV file, where you have three different settings available. You could set it that the recipe file is always downloaded with every Cscape download you perform. You can choose for Cscape to prompt if you want to download the recipe file, or finally you can set it so Cscape will only download the recipe file when there isn't one that exists on the micro SD card already. That way I can download and start out with the initial CSV file, and then if some parameters are adjusted and saved on the unit itself, and that file has become modified, I won't accidentally overwrite the changes that were made to the recipe file that I don't want. So let's go through that workflow once more. So we made sure we have all our process variables created. In my case, I usually start with a spreadsheet and I export that to a CSV file. Then we work on the Cscape recipe editor. Once we've created our recipes, we need to provide some method to actually load those recipes at runtime. We can also write some logic utilizing the load and save recipe function blocks. For this, we'll go into the graphics editor and we'll use the recipe object to build that capability into our screens. We can also write some logic utilizing the load and save recipe function blocks. Once we've completed the editing of our screens and writing our logic to incorporate whatever recipe functionality we need, then we can download our application. Let's begin our demo where I'll be showing how to do that whole workflow process for managing Cscape recipes. So I'll open Cscape. Here I have an application for paint mixing. The first step in our process is making sure we have our process variables created. In this application I have 4 process variables that I'll use as ingredients. I have 3 different dyes that I can use, and then I have a mix time variable. So the dye variables are going to be between 0 and 100%. And my mix time is going to be in seconds. The next thing I like to do in my workflow is create a spreadsheet that has my recipes incorporated. Here I have an Excel spreadsheet where across the top in columns I have my ingredients and the mix time. Then going down in rows are the different products that I'm going to be manufacturing, where my ingredient values vary depending on what product I'm creating. The next step is to export it as a CSV file, which I have done already. Cscape can't handle an XLS file or an XLSX file directly. It needs to be a CSV file. Next, I'll go to the recipe editor, which is available under the program menu. Here's my recipe menu. This is the first time I've come into this menu, so it's automatically asked me to specify this new recipe. Under recipe name, I'll call it paints. Why do you need to name your recipe function? Well, in a typical application, you could have multiple recipes. Now the file name you're being asked for is the CSV file name. I'll call that paints.csv. Next, I'll input how many products and ingredients we have. Here I have 4 ingredients, my 3 different dye colors and mixing time. Then I'll have 6 different products to start, which are the different paint colors that I'm going to be creating. When I hit OK, it automatically creates this spreadsheet. Instead of just manually filling everything in from scratch, I'll import in the CSV file that I created. I'll go to File, Import Data, then I'll import this paints.csv file. And as you can see, it automatically filled in the names of all my products and the values from my variables. What it didn't do is bring in the names of the different ingredients. I'll need to fill those in manually. That's not a big problem because, as well as a name, they'll also need to be configured so that they're tied to a particular variable. So I'll begin that process. My first ingredient is red dye, and I'll name it that. I actually don't need to use an underscore character because this part is just a descriptive string. Numeric is fine for the type. I want to tie this to a process variable in my program. I'll use the tag browser and tie that to the red dye variable. I want to use decimal format, and I'll use percentage for my engineering units. For my display format, I'll use 3 digits. I'm going to make this an editable field in my case, and I'll set the range between 0 and 100. I need to repeat that for each of my 4 ingredients. Next, I have blue dye, which is tied to the blue dye variable. 3 digits is all I need to display because it's a percentage. And again, I do want it editable, and I'll limit that from 0 to 100. Finally, let's do that with our yellow dye. Again, I'll tie it to a process variable, which is yellow dye. And again, we want to configure the process variable in terms of its number of digits, its format, and these are all decimal. Again, I'll make it editable, and when users are entering in values, we want to limit the value they can enter between 0 and 100. My last ingredient, my mixing time, is slightly different. It's still an integer, however, its engineering units are in seconds, so I'll change that to seconds. I'm still going to keep the display format as 3 digits because I'm going to say that the maximum I'm going to allow is 10 minutes or 600 seconds. That's the longest part in the whole recipe creation process. Another step after we've created our recipe is to configure our product register. This is the register that we can use in our logic program and on the screen to monitor what product recipe is currently selected. This can either be numeric, which is an index, or it can be the ASCII name. I'll use that ASCII name here. I've already created a variable which is a byte array that's 32 bytes long called paint mix current. I'll select the first element of that byte array. So that's the configuration complete. Next, we need to make sure that the spreadsheet file gets located onto the micro SD card on the OCS. We can manually take that CSV file and copy it over to the memory card, but we can also allow Cscape to do that for us. To do this, I'll go to Program, then Download Options, and down here in this section, that's where we decide when we want Cscape to download that spreadsheet file. In my case, I prefer only to do it when the file doesn't exist yet, so I'll do that when it's the first time I do the program download. I have other options as well, as you can see. We've completed all the configurations, now we need a way of loading recipes at runtime. We can do that on the screen or in the logic. Now I'll show you what I've done for my application. I'll go into the graphics editor. Here I'm using standard data objects to display the current value of each of my 4 ingredients. These objects are monitoring individually the variables that I have tied to my ingredients, so this is not specifically tied to the recipe function. Here I've configured functions for the Cscape recipe object. However, for the first object, I could have configured it as a view indicator for the Cscape recipe object, but I'm instead just using an ASCII text indicator here because I have more control over font size and other features. So here I'm monitoring that ASCII variable that I've created for the product variable. This is my byte array that contains the string for the product that's been selected. The rest of these three are actual recipe objects. I'm using the first one as a load push button. To configure this, first you have to select which recipe this is tied to, which is paints. Then you can select what button type we're using it for. And in my case, we're using load. And other than the legend, that's all the configuration that's needed. I've configured the next one as an edit button, and the last one as the save button. I'll show you how those work in the second part of our demo, where we'll look at our OCS. Next, I'll show you the load function block. Normally, you would use the load function for loading in a new recipe, but you have other options. Here, I've created a quick color selection with these 6 push buttons. These are all standard momentary push buttons, each tied to their own individual bit type variable. When those bit type variables turn on, they're going to trigger in the logic a recipe load function. So let's look at that in the logic. So I'm going to exit the graphics editor here, and I'll go to my select paint logic routine. Here's the one for violet. This is the bit that turns on when I press the push button when I want to load the settings for violet paint. When that contact is on, the load recipe function block executes and it loads the product violet paint. It's also got a status register tied to it, so if there's a problem with that, their status register will tell us. For each of the different products, I have a load recipe function block that I can use for loading that product's parameters. Now let's look at this application actually running on the OCS itself. So here's our application. You can see that currently the recipe that's loaded is violet. And I can utilize this load recipe function button to select a different recipe to be loaded. So I'll select that slate color. You'll see the parameters have changed and the product variable has changed as well. So that's the load function, which is one of the ways you can load a product. Again, when you press that button, you get a pop-up window that comes up with all of your different product recipes, and you can use the arrow keys to select the one you want and then press enter to trigger the load. However, there's another way we could do it, and that's the color select I created using the load recipe function block along with these push buttons. So I could select different recipes using this approach. When each of these individual buttons is pressed, we're triggering a load recipe function block, and you can see my parameters are changing. Finally, we have our other recipe functions. Let's start with the edit function. So let's say that for the slate color we want to change our mixing time from 103 seconds to 105 seconds. Using this edit function, I'll first select the slate paint, and then I'll change my parameter to 105. Now I can hit exit and exit again. Now I'll load violet, and then I'll load slate again. And you can see that we've changed the parameter from 103 to 105, and that was using the edit recipe object function. There is another way we can make adjustments, and that's by going in here and changing the parameters directly. I'll change our time now to 100 seconds, for example. I could then use the save button. The save button takes whatever the values currently are for the different ingredients that are included in that recipe and saves them away to the product that you specify, which in my case is slate. I hit enter, and it asks, are you sure you want to do that, as I'm overwriting that spreadsheet. So I'll say yes to that. Now let's switch to a different color, and then we'll go back to slate. And we can see that change was permanently made. If we just make a change, for instance, I'll change this to 30 seconds, and we don't do a save, and then if we switch to a different color and switch back again, you'll see that 30 seconds didn't stay permanently, and it was just a temporary change that never impacted the recipe itself. Thank you for joining us for today's tutorial, and the Q&A session will begin shortly.
Okay, a nice and straightforward start to recipe management. I don't see any questions relating to the webinar just now. So I shall take you back to my screen as always, which hopefully you can all see now. So we do have part 2 next week, direct follow on. The registration is up, so if you are interested in seeing part 2, you might as well get the registration done now. We follow that up with function blocks and then into some CScan webinars. We did have one person have audio issues today, so we will get this uploaded as quick as we can. And if anyone else had any issues, just drop us a mail so that we know these things are happening. But it looks like it was just the one person had an issue today. I'll just double check the questions panel again. That doesn't seem to be anything coming in. Okay. Thank you for joining us this morning, and we hope to see you again next week for part 2. Have a good day.